What is up, guys? This is Josh the Gamer here, coming at you with a brand new video. So today we are going to be continuing on our Quorum game development series, and we are going to be covering joints in this video. Now, what is a joint? Well, a joint is something that's used to create a connection between two items, and depending on the type of joint, it can cause different effects. So, for example, we can use multiple joints to connect many different items together, just like you can connect two items together. There are three different types of joints that are available currently, and those are the distance joint, the weld joint, and the rope joint. The first joint we are going to cover is the distance joint. Now, what is a distance joint? Well, a distance joint is pretty much the distance joint will pretty much force two items to maintain a set distance between them. The items that are in this joint will not be able to get closer to or farther from each other. So pretty much, think of it this way. Think of the two items that are used in that joint to be connected by an invisible rod, and this rod allows them to spin about the connection points. So since the items are allowed to spin around their connection points, torque can be introduced here. Now, to create a distance joint, we have to import that class. So let's go ahead and import that class before we start, getting into the actual juicy stuff. So right below our use statement for vector 2, we're going to go ahead and do use libraries dot. I spelled use wrong. Use libraries dot game dot physics dot, and then you're gonna want to do joints dot, and then there are different items. There are different classes here. We want the distance joint 2D. Now, why is there a 2D at the end of the class name? Well, specifically because there's also a distance joint 3D that we are not going to cover. Why? Because we are not in a 3D space. We are in a 2D space. Alright. So now what we need to do is we need to pretty much what we need to do is we need to set some vectors for points in which that little imaginary rod I was telling you about is placed, like the different ends where each end is placed at, in order for that connection to happen. So, as you can see, I already have the two vectors defined, connection point A and connection point B. We just need to set those vectors. So right here underneath this nice little comment I provided for myself for setting the vectors, we're going to do a connection point A colon set, and we're going to say 377.5 and then 277.5. Now this is very specific. I tested this specifically before recording this, so I knew what values I needed to enter in here, because as you can see here in our set position, these are not like full-on constants that are here. So I needed to know what positions these were at. So that's why I kind of have those very specific values, because that's where the center, or that's where I need to put them in order to, connect them. So anyway, Now we need to do a connection point B colon set. And this will be a 100 and 277.5. Alright. So now we have the vectors set for the different points in which we want our vectors to connect. You know, we want our now we have the two vectors set to the points in which we want our objects to connect at. So next, what we need to do is we need to initialize the joint. So first things first, we need to create a distance joint 2D object. So distance joint 2D, I'm going to call it joint. Then we need to do a joint colon initialize. And then this will take two item 2Ds and two vectors. Now, remember, drawables are item 2Ds, so we can pass our drawables in there without casting them to an item 2D. So let's go ahead and do that. A, B, connection point A, connection point B. Alright, so now that we have that done, we now need to add the joint to the current layer. So how do we do that? Well, we need to call the getCurrentLayer2D method or action that's from the game class. So getCurrentLayer2D. And then now we're going to use a concept called action or method chaining. So since this will return a layer 2D, we can use actions from the layer 2D class. And one of them is add a joint. And then it takes a joint. So we pass in our joint. And there we go. We now have our joint initialized. So as you can see here, I now have I have some angular velocity set, so we can see that these are indeed bonded together. So let's go ahead and do that. So save it, build it, run it, and now it should, as you can see there, they are, even though I only have one spinning, or one set with angular velocity, it's actually moving the other one too. That is specifically because they are joined by a distance joint. It's pretty cool. Alright guys, now that you know the basics of the distance joint, we are going to move on to the weld joint. Now, what is a weld joint? Well, a weld joint connects two items at only one point. And this can be used to glue the two items together, you know, at that point. Or the joint can be adjusted to allow the items some movement around the connection point. The initial, you know, like setting it up is very similar to the other joints. So for example, you know, it's actually very similar to that of the distance joint. However, there are a few modifications to the code. So let's go ahead and look at that, shall we? So first off, our first change has to be, instead of distance joint 2D, we're going to do weld joint 2D. And in order to have weld joint 2D, what you need to do is you need to import the libraries.game.physics.joints.weldjoint2D. Once that's done, you should get an error in your initialize method or action call. Just make sure that you have the connection point in which you want the connection to be on. So in this case, I'm going to say I want it to be on connection point A, so we're going to get rid of connection point B in there. So once we get rid of that, we now have our nice little initialize action called, and that's pretty much it for setting up the weld joint. Let's go ahead, save it, build it, and run it, and we'll see what happens. Now, as you can see, nothing is really nothing but the two items are moving, and they're not going anywhere closer or farther away from each other. They are staying in specifically the same distance from each other. And if you can't tell, the two, I'm going to zoom in on this. The two little circles also are moving around the screen. You know, as you know, the pixels are looking a little bit different because of their positioning on the screen, and I believe they're also moving, like they're also spinning because of the angular velocity. So that's kind of what's going on there. And that's why the joint is spinning around and around and around, because I have the angular velocity set. So now that we have the weld joint done, we're going to move on to the next joint. Alright guys, so our last and final joint for this tutorial is the rope joint. Now what is a rope joint? Well, a rope joint is actually very similar to the distance joint. The rope joint maintains a maximum distance between two items, but unlike the distance joint, the rope joint allows the items to be closer to each other than the maximum distance. So it pretty much acts as if there's an imaginary rope in between the items, keeping them joined together. And this also prevents them from going farther apart than the length of the rope. So yeah. So there's another. So this is actually the setup is also very similar. We just need to make a few changes. Instead of weld joint, we need to do rope joint 2D. Now you're going to want to import the rope joint 2D class from the libraries.game.physics.joints package. And then we need to change our initialize method, or method call, or action call, whatever you want to call it. So this takes two connection points. So connection point 2D. So not 2D, connection point A and connection point B. And then it also takes it in the two items that you want to join together. And then this also takes the maximum length of the rope, pretty much. So in this case, I want it to be 100. So then we add the joint and so on and so forth. Then it's done. Save it, build it, and run it. And there we go. There is our rope joint. So as you can see there, our items are now 100 pixels apart from each other, and they're rotating round and round, and they can only go a specific distance from each other. Pretty cool. So that is pretty much how you'd use joints using the Quorum game engine and the physics system that is going to be in Quorum 5.0 on June 1st. So thank you all for watching, and we will see you all in the next tutorial, where we will actually be starting on the 3D aspects of the Quorum game engine.